and nice to meet all of you. Lovely to hear the way you guys are just taking the initiative to bring coding, math, and all sorts of fun hands-on things that are going to make a huge difference to the kids' lives to your classrooms. Goal for today's session is to give you guys exposure to a new technology. Some of you guys might have heard about virtual reality, augmented reality, spatial computing. Anybody? AR, VR, metaverse, maybe? Yeah. And kids and the kids you guys teach are natives of this world. They play Roblox, they play Minecraft. Anytime you give them free time, they're probably playing a 3D game. And one of you talked about how one of the challenges in your classroom is holding their attention, is the engagement. And I think you'll find that if you teach coding through something that they absolutely love already, it just becomes that much easier, right? Even if they are impatient, like one of you said, and they just get started with the Legos without even waiting for instructions. I think if you give them the right experiences and worlds in which they can start hacking around and messing around, and you tie that to learning, then I think that self-exploration actually is a wonderful thing, right? So my goal today is to share with you something that a team of people and I have been working on based on about 14 years of experience trying to teach coding to kids. And it is inspired by Scratch. When I was at MIT, so one of you guys mentioned Logo. There were a couple platforms that came out of MIT. One of them was Scratch. Logo was already around at the time, and App Inventor. If any of you guys have heard about it, anyone heard of App Inventor? Okay, so some of you have. So I was part of the team that built App Inventor at MIT, and it was part of my master's work at the university. So I was there for my undergrad, and then stayed for my master's. And at the time, Mitch Resnick had already put out the Scratch thesis and had started building that thing. App Inventor didn't exist. It was a team of us that brought it into existence with the idea that, when you're trying to, well, at the time, the idea was just make it easy for anyone, kids or adults, to build apps. But my focus, because I've been teaching kids for so long, was to make it possible for young kids to build things that they want to build and that change the world, but that they don't know how to build yet. Things like mobile apps, because it's hard to do that. Today, what we're going to share with you is a different kind of platform. It is a 3D platform that we have built. And when I say we, it's a team of engineers and myself, and we're taking the same approach we took to Scratch or App Inventor or anything else. So building a platform that is quite open-ended. So unlike code.org, which has structured curricula and some others, it's quite open-ended. And on top of that platform, want to create lots of projects that we can share with you. And so today we'll share with you one simple project. And the goal here is well, twofold. One, we want to give you a project you can run in your classrooms. And second, we want to hear your feedback on what would be the most helpful thing we could do to help you guys bring this learning to life. And so want to have a little bit of a Q&A time at the end as well, where we can answer any questions you have. All right. Any questions from you guys before we get started?
Is this a web-based program?
Yes, it's a web-based program that also runs on iPads. And when the child publishes their game, and you guys will see this soon, they can actually run that game or experience on any device. So they can run it on a mobile phone, they can run it on an iPad tablet, they can run it on a Oculus or a Meta headset, like a proper VR headset. They can run it on all sorts of futuristic devices as well. Any other questions I can answer for you before we get started?
Sorry, when they log in with this, do they log in with their Google account to save their work, or how do they save it?
Yes, they'll be able to log in with their Google account to save their work, but we've actually done something specifically for this. We've made it possible for them to save their work without logging in. We call it anonymous logins, and it's something that you would have seen on other platforms as well. So you can always save a project anonymously. The only difference is it won't have your nice name next to it, and it won't have your name in the URL and all of those things. But there is anonymous saving for people who want to just try and don't want to give their credentials. One of the things we made sure, actually, I want to tell you a little bit about the platform I'll be showing you. So you guys who have used Scratch or code.org, you'll know that beyond a certain age group, it taps out. So in my experience teaching coding for more than a decade, I found that by like grade 4, kids are starting to be like, I want something more challenging, especially if you've done Scratch with them for grade 1, 2, and 3. And so that was one challenge I found with Scratch. And so we made sure that with Hatch, we can graduate students within the same platform from the block-based coding environment to a proper text-based coding environment. So that's one thing we made sure to do when building this. The second is we made it all about 3D, right from the ground up, 3D and spatial computing. So AR, VR, metaverse technologies. And so kids love, the scratch, like one of you said, I think it was Jesse, who mentioned the sound that kids make when they see the cat actually move. You're going to have the same sort of gratification here for the kids, except in 3 dimensions. So it's more like the world we live in and their day to day. And it's also more mathematically challenging in the sense that they're being exposed to spatial mathematics as well, right? Thinking in 3 dimensions. When you have X and Y axes, now you have a Z axis as well. And you're thinking about math in 3 dimensions, and it really expands the child's sense of spatial geometry, right, from a very young age. And third, we recognize that schools don't always operate in a laptop environment, so we made this iPad compatible and tablet compatible. So you can actually have the coding being done on a touchscreen and then run it on a touchscreen as well. So without further ado, I think we should get started. I'd like to share the platform with you guys. Maybe I'll start by showing you some examples of things that other people have built on Hatch, and then we will get started building something on Hatch together. How does that sound? All right, let me go ahead and share my screen. Let me know when you guys can see it. All right, great. So I'm just on the examples tab right now. This is a roller coaster created by a kid. This is the traditional game Flappy Bird, but visualized in 3 dimensions. Super fun to just see 2D games come to life in 3D. For more advanced students, so like I said, you can graduate from the basic stuff to more advanced stuff. This was actually built by a 10th grade student, much older. But the point of showing this is just to show that you can have 3D math, graphing calculators, and things like that built in the same platform using text-based scripting. This is a game similar to Minecraft where a ghost chases a little avatar and you just run around. This is a bowling simulation. Lots of physics goes into building something like this, by the way. A lot of math and physics. So I think, Meda, to your point, that coding actually helps you visualize mathematics and visualize physics. It's absolutely true. This is a shooting game with a lot of physics as well. How do you detect collisions between just the bullets of the gun and then the actual frisbees floating in the air? This is an airplane simulator. This is an augmented reality app where you can have a slingshot in your room, in your classroom, and the child detects the collisions between these things and causes the objects to displace. Underwater scenes, you can build solar systems. This is an augmented reality heart application where you can have a beating heart appear on top of a textbook, and it's interactive. Mazes, character animations, actual Minecraft environments built within this platform. This is a car police chase. This is a periodic table. So I want to make a point here about how, as teachers, you guys will be able to use this platform. Today, we're going to show you a very basic project that you can do, and we're actually going to show you this one, the rocket takeoff. We're going to show you how to make a rocket fly, because kids love space environments, and they learn mathematics and basic arithmetic from this one. How do you move objects in 3-dimensional space, and how do you animate something in 3D space? That's what we will learn. But as teachers, and we can help with this, you can actually build a bunch of STEM integrated curricula that brings math and science to life as well. So for example, for mathematics, making a character in 3-dimensional space jump has a lot of math in it. For science class, building a virtual reality periodic table of elements is another example. If I click play here, you'll see what these look like, these 3D experiences. It's going to load in a moment. Okay, so if you open this on a phone or on a VR headset, it's an immersive 3D environment, right? And you can see the atomic mass of everything as you hover on it. Every project built on Hatch is like that. Same with the rocket launch. I want to actually show you guys what this looks like. And we're going to run it on our phones too, because I want you guys to feel the power of that. So here's a rocket, right? It's a 3D space. I can look around and do this. I also want to show you guys this feature. Can you guys scan this QR code? Let's see what happens. So we've actually made it very easy for students and teachers to get started on their mobile devices to just open up any application built on Hatch. And those of you who have an iPhone, you can just use your phone camera to do this. On Android, I think it might require a separate QR reader. Let me know when you guys have it. It should show you a loading screen, and then you should see Rocket taking off on your phone. I'd love to see a thumbs up from you guys if it's worked. Yeah, Kenosha says yes.
I just don't see the rocket. I see the platform.
Oh, you see the
rocket.
Look up.
Oh,
look
there
up.
it is. It's all the way up.
Look up. It's all the way up there. And you can just refresh the page, and you'll have it start again in the beginning.
Oh, very cool.
Yeah. So this is something that your kids would be able to build in like 5 minutes. You can give them a design template, or you can let them design it from scratch. But today we're going to show you how it works in 5 minutes to build something like this, where we give you the design, and then the kid can modify it and then add the code on top. But what's cool about this is very frontier technologies. This is virtual reality on your phone. And then if you want, you can run it in binocular mode on an actual VR headset you have in the classroom. Or you can run it on a tablet. And I won't be able to show this to you today. We can do it in another session like this. But you can also, for those of you who have iPads in the classroom or things like that, show them how to make this rocket run in augmented reality, which means that strip away the starry sky, strip away the ocean and the mountains here, and have the rocket actually take off in the physical classroom, visualized through the eyes of the camera. And that's a very powerful feeling as well. And then you can build interactivity on top of that, AR. So this platform allows a child to use either their tablets or their laptops to code virtual reality, augmented reality, or metaverse applications. That's the summary there. And you can run those on any device. So back to this. Yeah, so a bunch of applications here. We're going to get started with a version of this product that is built for the younger kids. Remember, I told you we built this with all age groups in mind. We wanted to solve the problem that Scratch taps out after some time. And so what we did is we built a version that's called Hatch Kids, and then a version called Hatch. So the normal website is hatchxr.com, but the version we're going to use today is kids.hatchxr.com, and they're all linked to each other. So if you go to kids.hatchxr.com, and Ameda, can you just share that on the chat thread for people, that URL, as I'm doing this so that everyone has it? Here, I'll actually type it. There you go. I've sent the link, the URL, guys, on the Zoom chat. So when you land here, you will see this environment. Okay, so this is a completely free platform. You can build AR, VR, and 3D apps in the classroom. You can code with blocks for kids who are transitioning from Scratch or code.org or any of those tools. And you can also graduate them to JavaScript. What we just saw was a more advanced version of the same platform, which uses JavaScript. And everything is 3D, including the animation on the back. It's a very different kind of, it's the next evolution of Scratch. Now, with this, you can create advanced applications that are 3D VR. You can make augmented reality. You can build applications with speech. There's so much we could show you, and we won't have time all in one day. But just wanted you to know how this works. Now let's get started because it's late for all of you. We're just gonna click the new project button at the top right. And I'd love for you guys to do this with me. We can do it together. And if you have any questions, please do unmute yourself and speak up, because I won't be able to see all of your hands being raised since I'm on my screen share. All right, so if you click new project, we're trying to focus on gratification. We know kids love fast gratification loops. They love to be able to build in like 2 minutes and then hack around and then like take an hour hacking around. But they want that first thing to be there in 2 minutes, right? Something's very clear to us. So we made a bunch of templates that they can get started with. Later on, when your kids become more advanced, they can create an empty project. But right now, we're going to start with a rocket launch template. Before I click this, I'm just going to show you what other things exist. There's a maze template where your kid can navigate a 3D maze. There's a Minecraft template. Literally, the Minecraft world has been built within Hatch. If your kids love Minecraft, they can play around with this one. We actually, we have some of our projects that are Hatch self-paced projects uploaded on code.org. And they, over the last few months, have become the most popular projects on the entire code.org platform. You guys can check it out. We have a few hours of code, like 1 hour self-paced exercises on that. and the Minecraft ones and the 3D Mario ones are actually the most popular on there. So lots of environments. Today we're going to do rocket launch because I want to teach you as teachers, how do you move things around in 3D space and how this platform works. So just click this one. Any questions so far? All right, no questions. So guys, on the left side, you have a code editor, okay? On the right side, you have a preview window. There's a rocket that's already there. Thumbs up if you guys can see this too. Awesome, great, love it. Now, your kids are going to probably like the design mode quite a bit. And I want to show you that one. So you know how Scratch is, it's a workspace that has everything on one tab. On Hatch, you have 3 tabs that are very important for you to know. There's a design tab, there's a code tab, and there's a play tab. And the reason they're separate tabs is because we want to give lots of space for 3D designing. It's hard to do it in that tiny window like we do it on Scratch. And so here you have a 3D environment, and it's a full design system. So if your kids play Roblox and Minecraft, this is exactly like that, but built within the web browser. You can move objects around. I can select the rocket, and you can drag them along the Y, the X, or the Z axis. This is the Z axis. I'll show you the Y axis. You guys can try this. And if you're on your iPad, this will work. You'll just use your touch screen. You'll tap the object and you'll drag on your this thing. All right. There's a camera here, guys. I want to explain a very basic concept of 3D spaces. In 3D spaces, imagine you as a human walking around a 3D space. Your eyes are here, and everything that you see is from the vantage point of those eyes. And similarly, every 3D space needs a camera. The camera is the location from where you are seeing the whole space and you're rendering the whole space. So we can move the camera wherever we want, and it's going to make the output look quite different. And you see these like 4 lines that are shooting out from the camera. That represents the frustum through which you see the space. In 3D applications, you have a camera and you have a particular view that comes from it. So if I go to play, I'm going to see the 3D scene from the vantage point of the camera. If I move the camera, then all of a sudden I'm going to see it from there. So let me move it much closer to the rocket. So I'm going to move it along the Z axis, which is the front and back axis. And I'm going to go here. And now I'm much closer to the rocket. Now if I go to play, I'm way closer to the rocket. You see that? So this is the 3D space. In the 3D space, you can add anything. So if a child wants to add 3D objects, they have this plus sign at the bottom where it says add 3D objects. We plug into every single 3D repository on the internet. So you have access to millions of 3D objects all within the platform. And the things that kids love, they love superheroes, they love animals, they love all sorts of creatures. So you have a search engine here as well. Anyone want to give me something we can add to our space scene?
An alien.
Alien, there we go. So let's add an alien. I searched alien, you'll see a bunch of different types of aliens, and we can pick any of them. I'll just take this one, this weird looking one, and there it is. We'll leave him in the sky for now, okay? But I can actually put him anywhere I want. So we'll just leave him here. Okay, that's the alien. Just to give you some more demos, I'm just gonna add some ridiculous things like let's add an ocean and some rain in space. So let's add, this is the rain. Okay, now we have rain. Some of you might be able to see it on the screen. And I'm going to add an ocean. Okay, that's an ocean. Now I can modify the properties of any object that I add on the right side. So on the left side, you can select the object, or you can select the object by just clicking it. So in this case, I'm selecting the ocean on the left. You will see all the properties for the ocean on the right. For those of you who have used App Inventor or Thunkable or any of those applications to teach kids coding, it's the same concept. You have the object that you're selecting on the left, and then the ways of modifying that object on the right. So I want the ocean to maybe be a little less jaggedy. I'm going to reduce the number of vertices here. There's an ocean right here. Okay, I'm going to leave this there. Maybe I'll make the transparency of the ocean be a little less. Okay. So now I have this weird ocean environment. I'm going to go back to play just to show you what I see. Okay, now we have an ocean environment. It's raining in space, and we have our 3D rocket. The last thing I want to do is I want to show you how to maybe add some text, because kids love making that world they're making look very clearly like it's their world when they show it to mom and dad or when they show it to friends. And so I want to show you how to do that, and then we're going to start coding this. So back to design. On the design tab, we are going to add some text. So I am going to go move my Zoom window. One moment. Here it is. Okay. So at the bottom, you'll see text. Now there are options to add 2D text or 3D text. We can talk some other time about when you would use what kind of text. But right now, let's add some 3D text. So I select 3D. I choose a font. I'll just take this one. And it should add some random text to the environment. And I'm going to move it. It might take you guys a little bit of time to get used to how to move things in X, Y, and Z, but it becomes a lot easier. So the first time it's a little hard because we're so accustomed to the 2D stuff, and you have to kind of orient your camera. You can orient your view by just clicking and dragging. That's what I've been doing. You can also use your arrow keys on your keyboard to move forward, back, left, right in the environment from the editor's point of view. So I'm doing that right now. You can't see it, but I'm actually hitting the arrow keys to move around. Yeah. Okay. So this is the 3D text. Now I want one of you to give me your school's name, just to personalize this. Let's actually ask for Lorraine to maybe give the name of the school you teach at.
Lourdes, Lourdes.
Lourdes. All right. Lourdes. What's like the full name for it?
Well, it's Our Lady of Lourdes. But
okay, I'm just going to say Lourdes School just for the sake of
perfect.
Yeah, there you go, Lourdes School. So if a child wants to customize, they can name this as Lorraine's Metaverse. They can name it as Jesse's 3D World, Jesse's Moonlander, whatever they want, right? And this is just to personalize it so that when they show it to mom, dad, friends, there's a lot of gratification, and no one says, "Hey, there's no way you made this," because that's the gut reaction when someone sees a 3D project. Like, there's no way you made this, right? Because we don't have too many platforms out there that enable this kind of creation. So here it is, Lourdes School. We have our rocket. The rocket, for some reason, is under the moon. I'm going to move it a little higher. All right, here we go. I've done the design, and now I want to show you coding. Thumbs up if you guys are with me so far. Awesome. All right, let's go to code. Here it is, Lourdes School. Alien is there doing nothing, and we have this environment. Now let's teach you guys how to make things happen. So Scratch has this green flagged clicked event. Similarly, there is an event. You can click on the left side here, events, and drag when the green button, play button, is clicked. That's the event block that starts everything. And those of you who have done Scratch would be very familiar with the when green flag clicked block. All right. Now, as I drag blocks, what's happening behind the scenes is it's actually converting this into text-based coding. So if some of you want to teach your kids about what happens behind the scenes, under the hood, that's another thing Scratch does not do. We wanted to make sure we do. All right. So you can toggle the mode, show script, show blocks over here. So what I've done is I've dragged a single yellow block. I can zoom in here so that you guys can see it's super clear. And then when I go to show script, you will see I have just added an event block at the script level as well. All right. Now back to the blocks. When the green flag is clicked, every object that I have in my 3D space is visible on the scene layers over here on the left. So if I find my rocket ship, I can click the rocket ship and I will see all the possible event options here. Rocket.move forward for 5 seconds. Rocket move forward for 1 meter. That's what it says. It's being cut off. But here, I'll just drag this out. There we go. So, even on an iPad on the touchscreen, you can kind of toggle the modes here. So this is move forward for 1 second. You can have a drop down from where you can choose move backward, left, right. I want to do this one. Change the rocket ship X by 1. So if I drag this, I've written a very simple command that changes the rocket ship's X by 1 every time. Zoom out. All right, here we are. So I've written a simple command that changes the rocket ship X by 1. Now let's actually see what happens when I hit the green play button. Every time I hit play, it's moving to the right by 1. Every time I hit play. All right, you see it over here. And it stops when I stop hitting play because I'm only moving by 1. What is 1? 1 is 1 meter in the 3D world. If I wanted to move up, I would change the X to Y. You guys are probably familiar with how this works from scratch. Okay, so now it's moving up. There it is. Now, if I want to reload and bring my rocket back, I just click the reload button. And now I've written the code that makes the rocket move one time. How do I animate this, right? That's what I want to figure out. So to animate something, you could use a forever loop like Scratch has, or you could use what is called a timer in more advanced programming languages. So if you want to have a timer, you can drag that from the loops and timer section. And then you move this rocket ship Y within it. You can name the timer if you want. That's useful in a game where you have many, many timers and you want to remove some timers and things like that. You give the timer a name. Right now, we don't care about it. The interval is 2 seconds, and I want to make the rocket ship go up 1 meter every 2 seconds. So let's hit the play button. No touching. There it is. Every 2 seconds, it's moving up by 1 meter. And so for a child, this is already quite exciting because they're seeing a 3D application where a rocket is moving up, right? And so what you want to do now is help them understand the math behind the scenes and how do you make it move in a more smooth manner. And the way to do that would be to explain the concept of an interval in a clock. Every clock has an interval. What if we can speed up that interval so the clock runs faster and the rocket's motion can maybe be smaller in each interval, giving the effect of smooth animation. And I'll let you as teachers explain that to your kids in your own way. But what we're going to do now in the interest of time is maybe reduce this interval to something like 1 second, maybe even 0.5, and maybe reduce this to something like 0.2. And you should see it moving a little more smoothly. And let's try that out. All right, ready? Play. It's already moving a little more smoothly, right? Now, if I wanted to move more, I just increase this distance. If I wanted to move less, I reduce this distance, right? So I can maybe make it 0.1 and maybe make it 0.5. Let's try it again. There it is. Now it's giving off that vibe that it is flying, right? Now, I believe there is a flame here that's already been added at the design level, and we just want to turn it on. And so in 3D systems, in all game systems, these flames and these kinds of things are called particle effects. Let me find the block that turns the flame on. Here it is. I believe it's this one. Let's try this out. There it is. There's a flame now. All right. And that's already been added at the design level. If you guys wanted to change that around, we could do a separate design tutorial on how to change everything. But for now, maybe I'll just show you how to change the color of the flame. If you like open up this folder here, which is under the rocket ship, you'd see particle system. I select that. I see the properties on the right. I can see that there's a flame, which is a mix of yellow and red. I can make it something very different. I can make the flame be like bluish. There you go. And let's make this purplish. All right, let's see what happens to our flame. Play. I have to hit the green play button. Boom, there's my blue and purple flame and my rocket takes off, right? Now let's make this happen on our phones. Let's show you guys how to publish this because that's a very important part of how kids save their work and share their work. So I'm gonna move this rocket back and now I'm ready to publish. So at the top left, you'll see we haven't given this project a name. So I'm just going to call this Lord's School Rocket, right? I can publish this and I'm not logged in right now. So when I publish it, it asks me, do you want to log in and publish? Or do you want a quick publish? Quick publish was the anonymous one I was telling you about. So that if you want to show this to your kids, you don't want to bother with the Google stuff, you just do quick publish, all right? What it's going to do is create a unique link for my project, which can be shared, and a unique QR code for my project, which can be shared. Every child and every project will have its own QR code and its own link. So I want you guys to go ahead and scan this. Check it out. This is what we have just created. No login needed. And yet we've built something that is on the cloud. It's persistent. Anyone can upload it at any point in time and no one can take it away. So let's go ahead and try to open this up. All right. I have it on my phone. And to make it run, you guys will have to hit the green play button. And you can also rotate your phone and see that in like horizontal mode. Play. Boom. There goes my rocket with the blue flame, right? So in like literally 5 minutes, we have built this awesome 3D application where we have made a rocket fly in a world that's customized to be our own. And this is a project that you can easily do in 1 hour. And when you're going to have some brilliant kids who like finish this in 2 minutes, and then what? Then you challenge them to think about making the alien also fly, or adding a Superman and adding the Superman flying in a slightly different pattern than the rocket, or maybe adding a whale in the ocean and saying, hey, animate the whale rather than making it move up, make the whale move straight in the forward back direction on the z-axis or on the x-axis. You can have them extend the same concept you've taught them of arithmetic in three-dimensional space to new objects, and making, while the rocket flies up, other things happen in the same timer. If that's too easy for them, you could give them a challenge problem, which is, hey, I want the whale to move in a circle around the moon rather than moving up and down. That's going to keep them thinking for some time, right? How do you update on that plane, which is the X and the Z plane? How do you update both the X and the Z so that each time the timer ticks, it moves in a diagonal direction? And that's going to be super fun, right? So there are so many things you can do with the one simple concept we've taught to just tickle their minds. And the very different thing here is this is three-dimensional space. They're thinking very spatially, and it is challenging, but fun for them. And if they get bored out of that, there are so many more templates, so many more projects that they can do. And it's our goal as a team, as the Hatch team, to build a bunch of do-it-yourself projects for these kids across every subject: math, science, history. I didn't show you this today, but you can do a lot with language arts as well, and like foreign languages. So same way in Scratch, you can have the cat talk. You can have avatars in the world, and like your characters, like my whale and my rocket, could have a conversation. And there will be speech bubbles, and those bubbles can be in any foreign language. I can give you guys a quick demo of this actually, just to show you that it's possible. I'll make the alien say something. How about that? I'll make the alien say something in a foreign language. All right, so I'll go here and zoom out. Alien. Now, alien will have this voice and speech section and an AI section. You can have conversations. So alien, translate and speak. Let's try that one. Let's see if it works. This is similar to a Scratch feature, which allows the cat to speak. So how are you in Japanese? Okay, sure. Let's try Japanese and see what happens. And I don't know if you guys will be able to hear it because I have my headphones on, but you'll at least be able to see what happens to the alien in terms of the speech bubble when I hit play. Reload just to make sure. Nope, the speech thing is not happening. So let me delete that, make sure there isn't any issue with that command. The speech thing uses an AI API that's somewhere else. That one occasionally goes down. Let's just try it without that. There may be something with the speech. Yeah, okay. So the speech one is actually not available right now, but you can, when it is available, I'd love to show it to you guys because it's a super cool thing when kids get to see any 3D characters having a conversation in foreign languages, and very easy to do by just dragging blocks like this. So I'm going to pause here, and Medha, I'm going to hand it. So actually, I'll take questions, and then Medha, I'm going to hand it over to you. I'd love questions from teachers on how to make the most of this, or anything else we can help you with. Any questions?
It's just so cool.
Yeah, I think kids would just know what to do when they open it up because it looks a lot like the stuff that they play. That's been our experience.
Can you search for code?
I do have a question. I'm sorry.
Okay, go ahead.
Yeah, I heard two of you asking something. Go ahead.
Can you search for code? Like, is there a search box if you're like looking for a specific code to use?
There is in the advanced version. In the advanced version of Hatch, as you go to text-based programming, there is absolutely a search box. In this version, it's just you have to scroll through the list on the left side. But if that's a feature request that a lot of you have, hey, because we're the team that built this, we can actually add that. And that's, one of the reasons we do something like this. We like to be very close to the users of the product, and we love doing these kinds of workshops, and we're happy to do more. So if that is a suggestion, then as you use it, I'd actually love to hear feedback from your students. And I think Medha will talk about how we can remain as a community helping each other and improving this application for your students. So search box is one I'll keep in mind, but would love more confirmations of that as you guys use it.
I have a question. So if we're talking to each, in Scratch, they call them sprites. I don't know if you're calling them characters or they're just objects in Hatch.
Sure, let's call them objects.
Like if I want to create a different code for the alien or for the text, is there different spaces for it, or it's all in the same workspace?
It's all in the same workspace, and I'll tell you why. The Scratch concept of separate code for separate sprites ends up creating so many different workspaces, and a lot of switching between those workspaces. We wanted to allow people to build applications with multiple objects interacting in one workspace. And so what we did instead is we made that left sidebar where you just choose which object you're writing scripts for. And you will notice that when you drag a block, it actually has the name of the object as part of it. And that's more realistic in terms of how coding works. We want it to be more authentic to what's happening behind the scenes. So just let me define that for you. Let's say you want the rocket to move up, but the alien to move forward, right? In JavaScript or in Python or in any other language, when you start coding, it would generally be a function that you would call on the rocket object. It would be a function called on the alien object. So it would be rocket.moveUp, alien.moveForward. That's how you would write it in one script, right? Mm-hmm. It would not be the case that you would have a separate rocket file called rocket.js, and there you say move up, and a separate file called alien.js, there you move up. The way coding works is you have an action happening on an object. So we wanted to communicate that, look, there's an object and there's a behavior for that object, and it is on that object represented by a syntax, which in more advanced coding languages is the object dot the behavior. And you can actually translate that block script to JavaScript and see what's happening behind the scenes. So we wanted kids to start thinking in that way, so they will be graduating into the tech space, programming eventually, and therefore wanted them to have that. That's one difference we did versus Scratch, and that was intentional.
And can I just ask and along with that, so you're only pulling out one when the arrow is clicked. Right. So but if you're doing it in a sequence, how can you have two parallel things happening at the same time? It's not going to go in order.
Okay. You're talking about
how you wanted the alien and the rocket to go at the same time. Would you pull out two when clicked blocks?
No. So it's the same event, right? So you are you're starting the script once. When the green flag is clicked, you would
everything.
You would put the alien block and this other block inside the same when green flag click button. But there are many other ways to trigger actions in games. So for example, if you want, and this is all interactive, by the way. So unlike Scratch, here we have all sorts of touch detection, and because it's virtual reality, augmented reality, and 3D, we handle a lot of events. So when the scene loads and when the green play button is clicked is just one of many events. There's another event, which is when a collision happens. So for example, when the rocket collides with the alien, then you can start a script. Then you would be dragging a different yellow block. It would not be the when green button click. It would be the when collision happened block between these two objects, then do this. So we're teaching them about event handlers. These are functions that you can define on any event. The green flag, the green button being clicked is just one event. And so there are many ways to start scripts, but we're sticking to more of what we call that event-based programming model, which is also what they would do when they graduate to text-based programming. Yeah, because behind the scenes, it's a game environment, and we want them to learn how to handle events. Good questions, guys. It shows me that you really engage deeply with your curriculum. And actually, we don't want this to be a one-time thing. We would benefit a lot in terms of customizing this product for your students. And if you feel like you would benefit from ongoing sessions of this sort, we would be happy to do them. Medha, you are building a Facebook group where they can connect, right? Why don't you just talk about that for a moment and help them get on it so that this doesn't have to be a one-time Q&A session. would love for you guys to asynchronously ask questions in case you aren't able to today, or in case new things come up as you try to use it with your students. Jessica, go for it, please.
So currently I use CoSpaces with my students,
okay.
But obviously you have to pay for that and it's quite expensive.
Sure.
We've just bought a whole heap of merge cubes to go with CoSpaces. And we have like the VR goggles that we use with CoSpaces as well. Do you do any collaborations with Merge Cube or with VR goggles or anything like that? Or is it just on devices at the moment?
What kind of VR goggles do you have? Is it just generic or is it a specific one?
I think we have the Google ones.
The cardboard?
No, I don't know what brand they are. I can't remember.
But like it's a headset, right? With a binocular view. Yeah, so this will work with the binocular view. I don't think that's specific to any one coding platform. Those are just generic, and the logic behind the scenes is the same. So Hatch is a free platform, and you can publish things for those goggles and any goggles, like including the more expensive ones if you want to buy one for your classroom, like a Meta Quest device or anything like that. We intentionally made sure that it also works on a mobile device, because more often than not, that's what students, schools have, and they can show it to the parents at home whether or not they have a device. So yet the answer is Merge Cube support, no. VR headset support, any VR headset, yes. Any mobile device, yes. Any tablet device, yes. And augmented reality. So let me tell you something about the Merge Cube. The Merge Cube is a device that allows kids to experience AR. And the way we do AR is in a way which doesn't require any hardware or any sort of physical thing. So I think in your case, you might have had to order a bunch of cubes. In our scenario, what we did is we just made it an open thing. So anyone can download the Hatch mobile app. That is the companion app for this product. It's a free app. It has a special QR code scanner. So when you scan the same QR code that we were scanning right now using your normal camera with that special app, it would actually run that project in AR in your environment. So imagine your school classroom, you can have AR rockets flying without needing a Merge Cube. So the idea was to be as open as possible, the same way Scratch is as open as possible. Now, as a platform, we do build special curricula and we do offer special teacher training, which is what we do charge for. But the platform itself is free forever, and it's available in the school as well as at home, and all that stuff is just open.
Awesome. Thank you.
Yeah, no problem. And kudos on taking that first step for making this accessible to your kids. I think it's a very powerful technology. And I do think that by the time these kids are in college or even high school, I think the world is going to be very different. I think we'll be living in a mixed reality world. And the creators economy is going to be there in full force. And these guys are going to have jobs to do in the metaverse. They're going to be all sorts of things. All right, Meda, over to you to explain how they can be. Yeah.
I think Jesse has a question.
Jesse has a question. All right, go for it, Jesse.
Yeah, I got two questions actually to piggyback on Jessica's question. So if you create something in this platform and you want to use your Google, Oculus goggle or a Google Cardboard, will that translate? Will this platform translate into those different apps or different programs?
Yeah. In fact, no apps required. So the way the Cardboard works is you take your phone and you stick it in the headset, right? Am I right, Jesse? The one you're talking about is a version of the headset where you stick your phone in the headset?
Yeah.
So the way it works is we are able to render any of these projects you build on this platform in what's called binocular view. What that means is it sends a slightly different visual to your right eye versus your left eye, creating the 3D effect, which is exactly what your VR headsets do, the more fancy ones as well. So we've done that on our side to be able to render what you just saw as a 3D scene with the binocular view. So the answer is we are able to support those headsets as part of this platform. It's just a way to consume the content, right? So think of this as a 3D creation platform that works on iPads or laptops on the creation side. On the consumption side, it supports millions of devices, every single phone, every single tablet, every single VR headset. And I'll tell you the secret sauce. It's all browser-based. So if you have Chrome or Safari or any of these browsers running on your phone, on your tablet, or any of this, it'll support it. We do all of the VR magic, AR magic, etc. on that browser, and so it's all cloud-based and browser-based, which makes it super easy to get started. No installations required on anything. The only thing that you want to do installations for is the augmented reality stuff, which requires very special scripts running that detect planes in your classroom and are able to put our objects on top of that, right? That requires the Hatch app for iOS or Android, which is the companion app. And we can do a demo of that some other time.
Okay, and my second question is more of a suggestion. I'm a little lost in the VR world with terminologies that you're using here in your platform, but I do appreciate the block-based, some of familiarities in block-based. In your tutorials, I know you only have 2 up in the tutorial system. Do you have like supporting documents to kind of like a dummy's guide to VR creation or to the
give me a sense of what are some of the terminologies that you find to be new or more difficult here that'll actually help me identify the right tutorials to maybe share with this community, and also it will guide our future tutorial development.
Well, just right off the hand, like in the events, I mean, I when green play button clicked, when scene loads, I'm a little hesitant. Like, what do you mean by scenes?
Good question.
Then also, what about oh, there was one I just
there's a bunch. There's a bunch.
That was logger. What does logger mean?
Okay, fair. So the logger is actually just a way for children to understand how to debug stuff. They can actually log an event or log any piece of text or any sort of thing to the console. We have a console here. When kids start doing professional development, they'll have like an output console. And if you taught any other programming language like Python, JavaScript, etc., you'll know about this. So when something isn't going the way you want it to, as a developer, as a kid developer, you want to be able to figure out why it's not going as per plan. So for example, you can print out the value of a quantity and you can say, it's supposed to be this. Why is it not this? That's what the logger is for. But I get your point. And your point is that, hey, it would be helpful to have a tutorial that just explains what each of those events is on the left side. And your feedback is taken. Thank you.